Hello students, so today we will discuss about inductive effect. It's a very easy and common part in organic chemistry. So what is inductive effect? The permanent displacement of a sigma electrons along a chain of carbon atom due to the difference of electronegativity. So let me explain with example. Suppose any two atoms, they mutually share the electrons and form a covalent bonds having different electronegativities. Suppose any two atoms like hydrogen and fluorine, two atoms, hydrogen and fluorine, they mutually share two electrons and form a covalent bond, covalent sigma bond. So once they form the covalent sigma bond, they cannot share exact equally that bond pair of electrons. What happened? The more electronegative atom pull the electron towards itself and acquire the partial negative charge, and less electronegative atom acquires the partial positive charge. So more electronegative fluorine atoms pull the electrons towards itself and acquire the partial negative charge, and less electronegative atom acquire the partial positive charge. The arrow sign indicate that the more electronegative atom towards. And suppose any electronegative atom group attached with a carbon chain. Suppose I mention here carbon chain. First one is carbon 1, carbon 2, carbon 3, carbon 4. Attached any electronegative atom, suppose chlorine. Chlorine is more electronegative than carbon. So chlorine is more electronegative than carbon. So chlorine pull the electrons towards itself and acquire the partial negative charge. So less electronegative carbon atom acquires the partial positive charge. But remember that electron pulling power not stopped in the first carbon. It passed through the up to 3 sigma bond. That electron pulling power pass up to 3 sigma bond, means 1, 2, 3, means up to 3 sigma bond it passed through. So second one acquire the partial 2 plus and third one acquire the partial 3 plus. After that the electron pulling power is negligible, means almost zero. After that its electron withdrawing power, electron pulling power, it almost zero, means becomes negligible. So the first one is del plus, second one is del 2 plus, and third one is the del 3 plus. Why? The magnitude of the electron deficiency, first carbon is the higher, means the nearest carbon of the more electronegative atom, chlorine atom, electron more deficient, less electron is there compared to the second and third. So that's why the magnitude of the electron deficiency in the first carbon is higher compared to the second carbon, compared to the third carbon. Have you got my point? Means once the distance will increase from the reference atoms, the inductive effect will decrease. Once the distance will increase, the inductive effect gradually decreases. That's why the magnitude of the electron deficiency first carbon is higher compared to the second carbon, then third carbon. Again, any electron rich atom or electron rich group attached with a carbon chain. Again I mention the carbon 4, carbon 3, carbon 2 and carbon 1. That electron rich atom means we can consider here lithium. Lithium is a electronically rich atom. It pushes the electron. Lithium is electronically rich. It cannot pull the electron. Its electron negativity also less compared to the carbon. So it pushes the electron to the carbon chain. Push the electron to the carbon chain and acquire the partial पॉजिटिव चार्ज मीन्स लिथियम इलेक्ट्रॉन को पुश करके खुद पार्शियल पॉजिटिव चार्ज डेवलप किया है. सो कार्बन फर्स्ट कार्बन एक्वायर द पार्शियल नेगेटिव चार्ज. Here also same thing happen, not stop in the inductive effect in the first carbon. It pass through again 3 sigma bond, 1 2 3. After that it become negligible, we cannot consider. But second one acquire the partial negative charge, third one acquire the partial negative charge. So the magnitude of the electron reach, not here deficiency, here electron reach, the magnitude of the electron reach, first one is the higher compared to the second one compared to the third one. Have you got my point? So once the distance will increase, the inductive effect will decreases, means its effect will decreases from the reference atom. That's why the first carbon is acquire the more electrons compared to the second compared to the third. So first one acquire the more electron compared to the second compared to the third. Actually this will happen in the inductive effect in a hydrocarbon. If any electron donating, electron withdrawing group or electron withdrawing atom attached with a carbon chain, it always pull, means electron pull towards itself. That's why carbon chain acquire the partial positive charge. But any electron donating group, electron donating atom, electron donating group attached with a carbon chain, that time what happen? It pushes the electron to the carbon chain, it pushes the electron to the hydrocarbon, and it's develop the partial negative charge to the carbon chain. Okay, have you got my point? Okay, so next I can mention here, this is the permanent effect. This is the permanent effect. Why permanent? The electron displacement happening here, the electron displacement happening here in a hydrocarbon, it's not a temporary effect like resonance, it's a permanent effect. It's permanent effect and distance dependent. Distance dependent, why? Once the distance will vary, the inductive effect will vary. Suppose here I mention one distance will increase, the inductive effect will decreases. So it's a distance dependent effect, means closer to the hydrocarbon, it's change the partial charge, is change the partial charge more. Once distance will increase, it's not experience that much, not change that much. So is a distance dependent. And always remember, it pass through only sigma covalent bond, not sigma pi valent. Sigma covalent. Sigma covalent means once the head-on overlap happen in the orbital, head-on overlap happen in the orbital, that time only sigma covalent bond is happen. Sigma covalent, not sidewise overlap. So only sigma covalent bond, it pass through inductive effect, only pass through sigma covalent bond. So you have to remember 3 points, important points. So measurement, how to measure? How to measure inductive effect? Inductive effect does not have any exact value, it's a relative value. So if I mention one carbon atom attached with three alkyl group R1, R2 and R3 and attached with a hydrogen. Here hydrogen CH bond hydrogen carbon hydrogen bond is the standard reference point. We can consider I equal to 0 here. Reference point 0. Suppose that hydrogen replaced by any atom or group. Suppose I can replace by hydrogen any Z group. That carbon replaced by Z group. Then that group electron withdrawing power more than hydrogen. That group we can say minus I group. Electron withdrawing inductive group. Means that group electron withdrawing power more than hydrogen. This is the minus I group, electron withdrawing inductive group. Electron withdrawing inductive group. Minus I group, electron withdrawing inductive group. Suppose that hydrogen replaced by any group Y group, electron withdrawing power less than hydrogen. That hydrogen if I replace with any group, that group we can mention here Y group, replaced by hydrogen, replaced by Y group, that hydrogen electron withdrawing power less than hydrogen. So this group we can call electron donating group. This group electron donating inductive effect group. Electron donating inductive effect group. This is called plus I group. This one is minus I group, this one is plus I group. Means we cannot does not have any exact value. Inductive effect does not have any exact value. It's have a relative value. The CH bond means hydrogen is the reference point. If any group replaced by hydrogen and its electron withdrawing power more than hydrogen, this group we can call electron withdrawing inductive group. This is called the minus I group. If any atom or group replaced by the hydrogen, that group electron withdrawing power less than hydrogen, this is called the electron donating inductive group, plus I group. So two types of inductive effect is there, plus I effect and minus I effect. So I mention here plus I and minus I. First I mention the minus I group with the series of decreasing series. So first powerful electron withdrawing group is NF3 plus. Second one NR3. R means alkyl group. 3 alkyl group attached with nitrogen and nitrogen acquire the positive charge. Then SR2 group, then nitro group, then SO2R group, then cyano group. After that aldehyde, ester, acid, then halogen series came. Fluorine, chlorine, bromine, iodine. Then OR group, O-methyl, O-ethyl, that group. Then alcohol, alkyne, amine and phenyl. Both are the similar inductive effect, minus I effect. Then alkene, then hydrogen. Hydrogen is the reference one, standard one. After that means That one is the we collected from several books, and we mention in all book is mentioned like that. And plus I group is the NH minus group, first one, then O minus, then CO minus. O minus comes from alcohol. Once alcohol release the proton, then O minus is formed. Once acid is release the proton, hydrogen, then CO minus is formed. Then tertiary alkyl group, then secondary alkyl group, primary alkyl group, then methyl, then deuterium. So you have to remember that one, then you can solve the any question and answer. You have to remember very carefully. So after that we have to study what is the impact of inductive effect. What is the impact? We are understand the what is the inductive effect, but what is the impact of inductive effect? Inductive effect generally any acid basicity, acidity and basicity of the molecule we can explain by the inductive effect. And we can explain the bond polarity. Means bond polarity means once the different atom with different electronegativities they form the covalent bond, that time we can understand the what is the bond polarity. Bond polarity of the molecule we can explain by the inductive effect. Chemical reactivity means how fast reaction is going, how slow reaction is going. So reactivity of the chemical molecules we can explain by the inductive effect. Stability of the intermediates, reaction intermediates means once reactants form the product, in between one reaction intermediate is formed. That intermediate stability we can explain by the inductive effect. Intermediate means like carbocation, carbon ion, carbene, this type of intermediate we can explain by the inductive effect. So first we can explain the acidity, acid and basic acid property we can explain first by the inductive effect. Suppose acid property. Suppose any acid, carboxylic acid, release a proton means H plus ion and form a COO minus, this anion CO minus. This is acid, this is proton, and this is we can say that is anion or conjugate base So suppose any acid group OH, acid group attached with minus I group, any carboxylic acid group attached with minus I group, it pull the electron towards itself and it pass through up to 3 sigma bond. Then once pull the electron, that OH bond will more polar. The OH bond is more polar and easily it can release the proton, and its acidity will increase. Once proton will release, acidity will increase. So acidity directly proportional to minus I group. Once minus I group attached with carboxylic acid, acidity will increase. Why? The electron withdrawing power, pull the electron towards itself, and that OH bond easily polarized and easily release the proton. So acidity will increase. If any plus I group is there, if any plus I group is there, what will happen? The bond will stronger. The bond will, OH bond will stronger compared to the initial stage. The bond will stronger. So it indirectly proportional. Bond will stronger means it cannot easily release proton, means acidity will decrease. Acidity will decrease means suppose A प्लस आई ग्रुप इलेक्ट्रॉन पुश करने के वजह से ए बॉन्ड स्ट्रांग हो जाता है. बॉन्ड स्ट्रांग होने से ए हाइड्रोजन इजीली रिलीज नहीं होता है. जब हाइड्रोजन इजीली रिलीज नहीं होता है उसका एसिडिटी डिक्रीज हो जाता है. मीन्स एसिड मीन्स इजीली प्रोटॉन रिलीज करता है. हेयर क्या, इधर क्या होता है, ये बॉन्ड वीक हो जाता है. माइनस आई ग्रुप के वजह से ये बॉन्ड वीक होने से ये इजीली प्रोटॉन रिलीज कर सकता है. सो उसका एसिडिटी इंक्रीज हो जाता है. और प्लस आई ग्रुप के वजह से एसिडिटी डिक्रीज हो जाता है. सो इनवर्सली प्रोपोर्शनल टू द प्लस आई ग्रुप. और क्या है, ये एनायन या कॉन्जुगेट बेस, उसको एनायन बोल सकते हैं और केमिस्ट्री वाइज उसको कॉन्जुगेट बोल सकते हैं. एसिड का कॉन्जुगेट बेस. एक कॉन्जुगेट बेस का स्टेबिलिटी इंक्रीज होने से, कॉन्जुगेट बेस का स्टेबिलिटी इंक्रीज होने के से एसिड का स्ट्रेंथ बढ़ जाता है. मीन्स एसिड इजीली ए प्रोटॉन रिलीज कर देता है. इधर रिवर्सिबल साइन है, ए स्टेबिलिटी बढ़ने से इधर एसिड फॉर्मेशन फॉर्म होने का चांसेस ज़्यादा होता है. सो कॉन्जुगेट बेस का, एनायन या कॉन्जुगेट बेस का स्टेबिलिटी इंक्रीज होने से एसिड का स्ट्रेंथ बढ़ जाता है. तो मैं सपोज ए एनायन, सी डबल बॉन्ड ओ माइनस, इधर कोई माइनस आई ग्रुप है, इधर कोई माइनस आई ग्रुप है. माइनस आई ग्रुप रहने से क्या होता है, ऑलवेज चार्ज मॉलिक्यूल अनस्टेबल होता है. ये इधर चार्ज नेगेटिव चार्ज है, मॉलिक्यूल अनस्टेबल. ये चार्ज सपोज इधर डिस्पर्स हो जाता है, ये मॉलिक्यूल के ऊपर डिस्पर्स हो जाता है तो स्प्रेड आउट, मीन्स स्प्रेड आउट हो जाता है तो उसका स्टेबिलिटी इंक्रीज होता है. सपोज इलेक्ट्रॉन विथड्रॉइंग ग्रुप इज देयर, सो इस पुल द इलेक्ट्रॉन को खींच के वो नेगेटिव चार्ज का स्टेबिलिटी इंक्रीज हो जाता है. मीन्स चार्ज कॉन्सेंट्रेशन डिक्रीज हो जाता है माइनस आई इफेक्ट के वजह से. सो क्या होता है, कॉन्जुगेट बेस एनायन का स्टेबिलिटी इंक्रीज हो जाता है. सो एनायन directly proportional to minus I group. Suppose any plus I group is there, plus I group is there means is push the electron to the negative charge. Push the electron means charge is there, again is push the electron, so it will become more unstable to become more unstable. So anion का stability डिक्रीज हो जाता है. जब कोई प्लस आई ग्रुप रहता है तो एनायन का स्टेबिलिटी डिक्रीज हो जाता है. एनायन का स्टेबिलिटी डिक्रीज होने से एसिडिटी डिक्रीज होता है. सो इनवर्सली प्रोपोर्शनल टू प्लस आई ग्रुप. एनायन मीन्स एसिडिटी directly proportional to anion in so minus I group inversely proportional to plus I group. मीन्स प्लस माइनस आई ग्रुप रहने से एसिडिटी इंक्रीज हो जाता है और प्लस आई ग्रुप रहने से एसिडिटी डिक्रीज हो जाता है. लेट मी एक्सप्लेन वंस अगेन. सपोज एनी माइनस आई ग्रुप प्रेजेंट इन ए एसिड, कार्बोक्सिलिक एसिड, it pull the electron from the acid group and OH bond becomes weaker. So it can easily release the proton. It can release the proton and its acidity will increase. Any plus I group is there, bond becomes stronger. bond becomes stronger due to it push the electron to the carboxylic acid. Bonds become stronger. So bond becomes stronger means it cannot easily release the proton, means acidity will decrease. So acidity directly proportional to minus I group, inversely proportional to plus I group. Again conjugate base या anion, anion का stability increase होने से acidity increase होता है. तो anion means charge molecule, one charge is there, charge molecule always unstable. If charge will disperse through the molecule by minus I effect, it will become stable, so acidity will increase. If plus I group is there means that charge will increase, the charge concentration will increase, means stability decreases means acidity will decreases. So again one thing, that minus I group in same also that minus and plus I group depends on the distance, power and number. Distance, number and power. Distance, number, power. We will explain with the example in the next slide. We will explain next slide, distance, number and power. Once distance will increase means inductive effect will decreases, number will increase means inductive, suppose 1 2 3, number will increase means the inductive effect will increases. Power means we have to compare with power, fluorine is more powerful than chlorine. So we have to remember distance, number, power. So take a screenshot in that slide, and then we will go to the next slide. So have you understand? Have you got my point? Okay. So first example is acetic acid and 2-chloroacetic acid, means effect name ethanoic acid, 2-chloroethanoic acid. Which one is the more acidic? So remember, here one carbon attached with 3 hydrogen, here one carbon attached with 2 hydrogen and 1 hydrogen replaced with chlorine. So chlorine inductive minus I power is higher, minus I direct acidity directly proportional to minus I, inversely proportional to plus I. So chlorine minus I power, chlorine electron withdrawing power is higher compared to the hydrogen. So first one is the more, second one is the more acidic. If I compare, that one is 1, that one is 2. Second one is the more acidic due to chlorine electron withdrawing power is higher. So electron withdrawing power higher means acidity will higher. Here see fluorine, chlorine, second one fluoroacetic acid, chloroacetic acid, bromoacetic acid, iodoacetic acid. So all acetic acid here replaced by one halogen. First one is fluorine, chlorine, bromine and iodine. So electron withdrawing power fluorine is higher due to fluorine is more electronegative than chlorine, than bromine, than iodine. So electronegativity series is fluorine, chlorine, bromine, iodine. So electron withdrawing power also same, fluorine, chlorine, bromine, iodine. So fluorine is more acidic, means A is more acidic compared to B, compared to C, compared to D. Due to iodine is the least electronegative, so minus I power increase means acidity will increase. So here So powerful inductive, powerful minus I, powerful is fluorine is more powerful. I mentioned here na, charge, power, distance and number, power, distance and number, power, distance. So fluorine is more powerful minus I, so is more acidic than chlorine, than bromine, than iodine. Here see acetic acid, yeah, ethanoic acid, one hydrogen is replaced by chlorine. Second one, 2 hydrogen replaced by chlorine, 3 hydrogen replaced by chlorine. So first one single chlorine, second one is 2 chlorine, third one is the 3 chlorine. So number of chlorine increases, number of chlorine molecule increases, means number of electron withdrawing power increases. Number of electron withdrawing power increases means acidity will increase. Minus I power increase means acidity will increase. So third one, C1 is more acidic compared to the B, compared to the A. Have you got my point? Means number of chlorine atom increases. In number of chlorine atom increases means number of minus I effect will increases. Number of minus I effect increases means acidity will increases. Here see 2 nitro acetic acid, meth, eth, prop, 2 in oic acid and fluoro, 3 fluoro propanoic acid. So here this side is the same, this side is the same, this side is the same. So only here one hydrogen is less, one. So fluorine is there, so we can go to the series. You can remember nitro is the first one, then here fluorine, then here alkene. So nitro is the more powerful minus I group, more powerful compared to the alkene, compared to the fluorine. So nitro is the more powerful electron withdrawing group. So minus I, more powerful minus I effect means acidity. First one is the more acidic, then the third one C, then the second one B. Means if you see the series, powerful series, then nitro is the more powerful minus I group. That's why first one is the more acidic, then see third one fluorine, then at least is the alkene group. So this is the acid order. Here formic acid and acetic acid, methanoic acid and ethanoic acid. IPAC name methanoic acid, ethanoic acid, trivial name formic acid, acetic acid. So here see, here one hydrogen is there, here one methyl is there. Methyl group is a electron donating group, plus I group. Plus I group present means acidity will decrease, inversely proportional, acidity inversely proportional to plus I group, and hydrogen is the minus I group. So acidity is higher in formic acid more acidic compared to the acetic acid. So here 4 alcohol, we have to compare the acidity of the 4 alcohol. First one tert-butanol, isopropanol, ethanol, methanol, methanol, tertiary butanol, isopropanol, ethanol, methanol. So if you observe that one, OH group attached with methyl group, one methyl group, and all are plus I group. Here all are OH, all are attached with plus I group. So powerful plus I group means first one, then second one, plus I group, plus I powerful plus I group A, then B, then C, then D. So plus I inversely proportional to acidity, inversely proportional to acidity. So acidity order will reverse, acidity order will reverse. Acidity A means D1 is the more acidic due to plus I effect. If you see the order, less plus I power is the less compared to the other. So D is the first more acidic, then C, then B, then A. This is the acid order. Here 4 acid is there: formic acid and acetic acid, phenol and benzoic acid. Benzoic acid, formic acid, acetic acid, phenol, benzoic acid. 3 are acid, 1 are alcohol, aromatic alcohol. So we cannot compare. We can compare with that one, we can compare with that one, but we cannot compare with 4 molecules. How? So we have to remember the pK value of that molecule. pKa value. pKa value means suppose any acid HA, reversible sign dissociation, H plus means H plus release and A minus is the anion. So first Ka is the dissociation constant, acid dissociation constant, product concentration H plus, anion concentration divided by acid concentration. This is the acid dissociation constant, and pKa equal to minus log Ka. Once pK value will increase, acidity decreases. pK value increase means acidity will decrease. So this is the experimental data. So we have to remember that series. You have to remember this is experimentally. You have to measure the pK value. So first one is the sulfonic acid, second one formic acid, then benzoic acid, then aliphatic acid, then H2CO3, then phenol, then water, then alcohol. This is the experimentally observed, pK value we observe, then we can compare that series. So A, first one is the more acidic due to formic acid more acidic, then benzoic acid D, benzoic acid, then acetic acid, last one is the phenol. So alcohol, aromatic alcohol always less acidic compared to the aliphatic या aromatic carboxylic acid. Aliphatic या aromatic carboxylic acid से phenol, aliphatic alcohol या aromatic alcohol always less acidic. So first one A1 is the most acidic, then benzoic acid, then acetic acid, least one is the phenol. So here benzoic acid, phenol and 4-methyl benzoic acid. So we can compare. First one is the more acidic. Here electron donating group is there, so always aromatic acid is more acidic compared to the aromatic alcohol. So A, B and C. A and C is the more acidic compared to the phenol. due to this is the aromatic alcohol. So A and C, in A molecule no electron plus I group is there, but in C plus I, 1 plus I, methyl plus I group is there. So A1 is the more acidic, then C, and last one is the B. So this type of question we have to solve by the pKa value, This is experimental. So next we will discuss about basicity. See, the basicity, we have to compare the basicity of the molecule. Basicity means electron availability of the molecule. Electronically rich means basicity is higher. So basicity directly proportional to plus I effect, inversely proportional to minus I effect. Minus effect means that electron availability, if electron availability electronically rich group means basicity of the molecule is higher. So here that comparison of the basicity of the molecule in solvent phase, not aqueous phase. So suppose here NH3 is there, that one is methylamine, dimethylamine, trimethylamine. So here no electron donating group is there, here one electron donating group is there, here two electron donating, 2 methyl group is there, means 2 plus I group is there, here 3 plus I, no plus I there, 1 plus I, 2 plus I, 3 plus I. So 3 plus I group is there, means electron donating power of the fourth molecule, electron donating power, that one is A, B, C and D. The D molecule electron donating power is 3. So that nitrogen electronically more rich, the electronically more rich means the basicity of the molecule is higher, So basicity of the fourth molecule is higher compared to the other molecule. Here 2 plus I is there, means basicity of the molecule is less than fourth molecule but higher than second molecule, and NH3 is no plus I group is there, means that basicity is the least basic of the molecule. But this one is the we are comparing the anhydrous condition, anhydrous phase, solvent phase. Here 3 molecule is there. If I compare, that first molecule is sp3, second one is sp2, third one is sp3. So percent of S character higher means sp2, sorry, this one is sp3, sp. Percent of S character higher means sp. Percent of S character 50%. That one is 33.3%. That one is 25%. S character higher means electronegativity higher. So that nitrogen lone pair electronegativity higher means that nitrogen sp2 nitrogen, sp nitrogen, that nitrogen is sp2, that nitrogen is sp3. So sp nitrogen electronegativity higher due to percent of S character is higher. Percent of S character, once percent of S character will increase, the electronegativity will increase. So percent of S character higher means that nitrogen cannot easily donate the proton, cannot easily donate the proton. So that basicity is less, compared to the second, third. So first one is the more basic. Why? That percent of S character is less, it can easily release the proton, it can easily donate the proton. So electron donating power is higher in the first molecule, then second molecule, then third molecule. Basicity higher of that first molecule, then second, then third. The last problem is the stability of the intermediate of the molecule. I just give example, only one example of the carbocation of the molecule. This is the intermediate of the reaction. Here that one is the 3 degree carbocation means that carbocation plus charge means carbocation, plus charge there means carbocation. 4 carbocations there. First one is the A, second one B, third one C, fourth one D. So here carbon acquire the positive charge, means electronically less electron is there. Charge molecule always unstable. Here 3 methyl group push the electron. Methyl group means electron plus I group. 3 plus I group is there. 3 plus I group push the electron to the carbon atom and minimize the electron deficiency and increase the stability. Here 2 plus I group is there. 2 plus I group push the electron and increase the stability of the carbocation. Here 1 plus I group is there, and last one no plus I group is there. 0. Once the plus I group will increases, electron donating group will increases, the carbocation of the molecule, stability will increases. So here first one stability is higher due to 3 plus I group is there. Then second one, here 2 plus I group is there. Then third one, and last one no plus I group is there. So that's why is the least stable. So first one is the more stable molecule of that 4 carbocation.